inventory models are also models that come under operations research. And in inventory models, what we really try to do is we try to uh, estimate what would be the average inventory that a firm should maintain so that they don't get outstocked and it affects their production. And on the flip side, they also do not want to keep too large an inventory, and all inventories involve a cost, and therefore, to optimize the cost, the inventory models are studied. So, in this presentation, besides giving a brief introduction about inventory models, we will be estimating the economic order quantity. And based on the economic order quantity, we also find out what is the cost of an inventory. And when firms offer price discounts for bulk purchases, we examine how it affects the economic order quantity, whether it remains economic order quantity or do we revise the quantity depending on the amount of price breaks or the price discounts that are given for large purchases. Then, in order to set a standard, when there is a lead time, that is when we place an order for an inventory and the inventory takes some time to come, maybe 5 days, 6 days, then what should be the level at which you should reorder? So in such cases, we don't allow, when there is lead time, we don't allow the inventory to become zero. And we place an order when the inventory has come to a particular level, and that particular level is referred to as the reorder point. And sometimes the reorder point needs to be adjusted because demand may not be constant and therefore we have to keep what is called as a safety stock to cater to certain spurts in demand that may occur in a particular cycle. And finally, we discuss the single inventory model, single period inventory models, where we will be finding out how it impacts the inventory holding. So what are the decisions that we take when we study and compute inventories? First, what we need to know is what is the demand. What is the demand for your product? If you're dealing in shirts, then what is the demand for shirts for the year? So you should have an estimate of the demand, or you should have data that should be decided based on your data. You should know what is the cost of purchasing that item, which is referred to as the inventory cost. So that is the cost of the inventory. I mean, how much does that each item of that inventory cost? Then, of course, there is a storage cost. So when you keep a particular stock in storage, there will be cost associated with storing it, which includes the space, the people who manage the space, and there could be a lot of costs involved with storage. Then you could also, when you have an inventory, then probably you'll also have to take insurance against fire, loss, theft, deterioration, so on and so forth. So that is also a holding cost. And there'll be other maintenance costs, like if it's a perishable, then you may have to fumigate it. Then if it's a non-perishable, then you have to stack it and you need bags and various costs. So you have to make an inventory of make a list of all the costs involved in inventory. Okay? So these costs have to be decided. And there's also an ordering cost. Sometimes when you place an order, there are costs associated with that. So that's called the ordering cost. So inventory decisions basically boils down to how much do I buy? When should I buy? And where should I buy from, therefore, to get the lowest price? So this is basically what an inventory model looks like. So inventory models are basically decided are employed to find out what is the minimum inventory that you should maintain so that at no point in time you get outstocked. Because when you get outstocked, it's quite likely that you may not be able to meet the demand, and that could lead to a loss of goodwill and you could get penalized by the customer and there could be losses associated with that. So basically what happens, you start with an inventory and over time that inventory gets drawn down depending on your demand and the consumption. Then at some point when it reaches a critical level, then you replenish the inventory and the cycle goes on over and over again. So all this happens on time. Now, when we talk about economic order quantity, right, we're basically trying to find out what is the level of inventory that we should maintain. Now, if you're dealing in tires or you're dealing in wheat and there are people buying products from you, you should roughly have an idea what is the demand per annum. Right? Similarly, a pushcart vendor who's dealing in, let's say, a particular vegetable like onion or tomatoes, he or she should know roughly what is the demand for the day, because her inventory or his inventory will be for the day. So the first thing in an inventory model is to decide the inventory levels. You should know the demand, right? You should know, and then that will tell you how much you should order, and that's the calculation that we're going to do now for you. So this is going to change over time. So this is the demand. So this is the rate at which your inventory gets drawn down, which is again related to your demand rate, right? So depending on the demand rate and the lead time, because I told you lead time is the gap between the time you place the order for the inventory and when you get it. That's when you place the order, because that is again decided by the lead time. Then it gets replenished. So when you place the order at the beginning of the lead time, the inventory comes, when the inventory stocks have almost come to zero, the inventory gets replenished, and then the order, that is the point at which you will do the reorder. That's called the reorder point, because you don't wait for the inventory to come to zero before the order is placed. And then that inventory again gets run down. Again, you place the order at the at the reorder point, and the process continues for the whole year. Now the challenge here is to find out what is the Q, order quantity Q. We need to find out this. Okay, then the order is received. And then, of course, it gets replenished. You place the order is received, it gets replenished, and the cycle comes down. The reorder point is known as R. Now, so when the stocks come to that level, now supposing you are having an inventory and it comes to a particular level, then you immediately place the order. And by the time that particular quantity which is with you gets exhausted, the new order will come. And that is referred to as the reorder point. Okay. Now, all of this involves costs, right? You have costs and there's a quantity. So this is called the ordering cost. The ordering cost. So as you order larger and larger quantities, the ordering cost comes down. Not because the cost per unit is coming down, it's because you'll make fewer orders. Supposing you make one order, then there's only one cost. But alternatively, supposing you make many orders, then it will be each order times the ordering cost. So the ordering cost declines with the size of the inventory, with the size of the order. So at the extreme case, supposing you make only one order in a year, then whatever the cost is incurred only once. Alternatively, supposing you make 10 orders in the year, then the ordering cost gets multiplied by 10. So the ordering cost comes down with and the ordering cost is calculated as SD divided by Q, where S is the ordering cost, that's the cost per order, D is the demand, annual demand, Q is the quantity. So as the Q changes, you can see the ordering cost comes down. This is called the holding cost. Holding cost is calculated by holding cost per unit into quantity divided by 2. So you can see that the holding cost is increasing with the holding quantity. Because here it's inversely related, here it's directly related. So this is the holding cost calculated as HQ divided by 2. And then you get the total cost, which is sum of the holding cost and the ordering cost, and that's called the total cost. And the optimum inventory takes place at the point where the total cost is minimum. And that is what we are trying to find out. And that will be the minimum cost. And this will also decide what's going to be the size of your inventory. So this is basically the principle. So the optimum inventory or the economic order quantity Q star is that point where the total cost is the minimum. Now we'll go into the calculation. Now how do we calculate the economic order cost? Now the economic order cost, I'm not getting into the derivation, I'm just straight away giving you the results. So the economic order quantity Q star is calculated using a simple formula, which is 2 into the total annual demand, ordering cost S, and the holding cost H. So D is the demand, Q is the order quantity, which of course we're going to find out the optimum. Cost S is the cost of, that is ordering cost, or cost of placing the order. That's ordering cost. And H is called the holding cost. So as I showed you earlier, ordering cost is calculated at SD divided by Q. Holding cost is calculated as HQ divided by 2. And the total cost is SD divided by Q plus HQ divided by 2. Okay, that gives us a total cost. So this is a simple formula that will help you to arrive at the economic order quantity. Now, let us take an example. A firm in the business of producing processed food products has a requirement of 112 tons of wheat per annum. Should you maintain an inventory if the lead time of ordering is 15 days? Ordering cost is estimated at 500 rupees per order, and the holding cost is estimated as 75 rupees per ton per annum. What should be the economic order quantity? So here we must break it down into the demand, lead time, ordering cost, holding cost, and substitute it into this formula that we saw earlier. Right? So here let us see. We'll come back. So now I'm going to put numbers. The annual demand is 112 tons. The ordering cost S is 500 rupees per order. And the holding cost is 75 rupees per order. And the Q has to be calculated. So using this formula. So it's 2 into 112 into 500 divided by 75. So that is. So the whole thing comes under the root. The whole thing is coming under the root. So that boils down to square root of 1493.33, and when you take the square root, you get 38.34 tons, which means that your economic order quantity should be around 38.34 tons. So that's your economic order quantity. So we get it over there. And when we use this formula, then once we know the economic order quantity, then we can calculate the ordering cost, which is I told you earlier was SD divided by Q. S is 500, D is 112, and I will just substitute the Q over there, and I get the ordering cost is 1460.62. Now coming to the holding cost. So holding cost is H into Q divided by 2, and that gives me a value of 1437.75. When I total up the 2 and this, I'll get the total cost as 2898.35. So you keep that in mind, 2898. Now any quantity other, now let me take 50. Supposing I take this as 50. Okay, so I'll go back here and I will say 500 into 112 divided by 50. 500, so any value other than this will not be the most appropriate one. Okay. You could just calculate it yourself. Now let's say that I arbitrarily decide that 50 is my economic order quantity. So then my holding cost will be ordering cost will be 500 into 112 divided by 50. So that gives me a value of 1120. 1120. Okay. So that will be the order. So I'm just taking a quantity other than the economic order quantity. So I get 1120. Now let me do it for the second one. For the holding cost will become 75 into 50. I'm just taking a hypothetical figure divided by 2. So that gives me 1875. So 1875 plus 1120, which is the ordering cost, gives me a total cost of 2995. So any deviation from this economic order quantity will increase the cost. And similarly, if you take a smaller quantity, suppose you say, no, I don't want to buy it at such large cost, I will buy only 10 tons at a time. Then my calculation becomes 500 into 112 divided by 10. My ordering cost becomes 5,600 and my holding cost becomes 75 into 10 divided by 2. Into 10 divided by 2. That gives me 375. So 375 plus 5,600 gives you 5,900. So ordering in small quantities or ordering in larger quantities than the economic order quantity can only increase your total cost of holding the inventory. So it makes a lot of sense to use the economic order quantity to decide what should be the optimum. So it's got widespread application because a lot of people are in the business. FPOs are using, FPOs are buying a lot of quantities. How much should they keep? What should be the optimum quantity? Should be scientifically decided using inventory theory. Now let's take another example. A beverage company has a soft drink product that has a constant annual demand of 4 lakh cases. A case of soft drink costs 3,000 rupees. Ordering costs are 1,000 per order and holding costs are 1% of the value of the inventory. That is 1% of this. The firm has 365 working days per year and the lead time is 2 days. Identify the following aspects of the inventory policy. So we're coming back to this. So I substituted these numbers, 4 lakhs. Placing an order is 1,000. Cost of the case is 3,000. Now here you should be very careful. Now he's given you the ordering cost, the inventory cost as 1%. So you cannot put 1% here. It will upset your calculations. You must find out 1% of this 3,000, which is your cost of your inventory. So 1% of 3,000 becomes 30. And now we'll go straight into calculating the economic order quantity. So it is 2 into 4 lakhs into 1,000 divided by 30. 2 into 4 lakhs into 1,000 divided by 30, which is nothing but the square root of 2666666.67, which gives you an inventory of 5,163.98 cases. So you should keep only 5,164 cases or thereabout. So unless you do that, you will be keeping too much of an inventory and your cost of inventory will go up and the damages and the space that you require. Whole lot of problems. So this is the economic order quantity calculated using a simple formula 2ds by h. So now I will substitute that over there and then I'll substitute it over here and I'll get the cost as 77,459.63 will be my ordering cost. My holding cost will be 3,72,952 and my total cost will be the sum of these two will be 3,50,000. So any increase or decrease below this level or above this level will only increase your inventory cost and contribute to it'll add to the cost and therefore it'll get subtracted from your profit. So now we have got the two examples here. We got the economic order quantity. In the first case it was 38.34. In the second case it was 5,163.98. Now coming to the reorder point, we will discuss that in little great detail. In order to get the reorder point, please see the calculation. We know the lead time is 15 days. We know the demand, because the firm works for 365 days. The daily demand is 112 divided by 365. Okay, 112 tons is your total annual demand for wheat. And now when you divide it per year, so it becomes 112 divided by 365. That means every day your demand is 0.3 tons. And for 15 days, which is your lead time, it will become 4.6 tons. So 4.6 tons is your reorder point. So moment your stock comes to 4.6 tons or for 4.5 tons, immediately you place the order. Otherwise, it'll get outstocked because it will take 15 days for the thing to come to you and you'll get outstocked. Right? Now you want to know how long will this last. That's called the cycle time. The cycle time is average inventory, that is 38.34, divided by daily in 0.3. So your inventory is going to last you for 128.56 days. So little over 4 months. Little over 4 months. And the total inventory cost is 2,898.37. Right? Now you see the other example. The same thing we have repeated. I've calculated the lead, for a lead time. I multiplied by the daily demand by 2,000 by 2, and I get 2,191.78. Every inventory lasts me for 5.71 days because it may be a perishable. So I don't keep it for less than a week. and my total cost works out to this. Okay. But sometimes what happens is you could end up, this lead time can be a variable. The lead time can be a variable. Similarly, the demand can also be varying. It won't be exactly 112 tons. It won't be exactly 4 lakh tons. I'll have a mean and a standard deviation of demand. You can understand, no? The demand is not the same. Every month it is not the same. Though the annual demand may be 112, but the monthly demand is not 112 divided by 112 divided by 12. You don't get it like that. It doesn't work that way. Some season you may find that the soft drinks have a greater demand. In such case, what we'll have to do is we'll have to keep what is called as a safety stock. Okay, that we'll come to later. And some important characteristics of the economic order quantity cost function. This is very interesting. As the economic order at the economic order quantity, the annual holding cost is the same as the annual holding cost, because you see that's where it intersects. You have seen that, no? They intersect, so they have to be the same. Okay, it's obvious, no? Exactly, bang on there. Okay, I'll just get back there in that this thing, no? Yeah. Here it has to be the same, no? They meet, no? They have to be the same. The cost, this cost and this cost has to be the same. Though in our calculation it's not actually not exactly the same. So that will be the same. So then how do we calculate? Then the calculation becomes even more easy. So the annual holding cost is always h by q star by 2. Now this he rearranges, he makes h by 2, and q star he substitutes it with this. Then he rearranges the term, this and this cancels, and this cancels, and you're left with, because this is inside under root and this is outside the root, so this comes inside the root. So you can get the holding cost as just simply by multiplying demand by holding cost by ordering cost divided by 2. Okay, now let us do the ordering cost. Now when you come to the annual ordering cost, it is ds by q star. We've discussed this earlier. So instead of q star, I use 2 ds by h, which is nothing but the economic order quantity. And then you can see we rearrange the terms. This will be ds into ds. Sorry, this will be ds into ds. So one gets cancelled. And this ds comes under the root. So this also becomes dsh by 2. So you can just simply calculate the total annual cost as 2 into d into s into h. So, 2 d s into h under square root will straight away give you the annual cost. So you need not go through that long procedure. You can just get total annual cost. Total annual cost is 2 into d into s into h. So that's simple, easy to remember, and there'll be no problem. Now, we very often in companies, you will find that if you buy a large quantity, the vendor will give you a discount. Now, how do you incorporate that into your calculation? Is the economic order quantity valid, or does it shift? Okay, so this is discussed under what is called as EOQ with price breaks. Very important, because if you can take advantage of a price break, maybe you can alter the EOQ so that you can take advantage of the discount, and thereby reduce the cost of inventory even further. So here the assumptions are the demands occurring at a constant rate, okay, at D items per year. So demand is constant, D for year. So I can find out. Ordering cost is S, we normally refer to as S per order. Holding cost is H, or it can be C into cost of inventory, okay, like we did in the second example. But it should be a per unit. The value you should get is per whole unit per year. Note that the holding cost is based on the cost of the item. So purchase cost is R into C1 per unit. That is, if you want to know how much you're going to buy, so it will be R into C1 units if the quantity ordered is between 0 and X. R into C2 if the order quantity is between X and X2, and so on and so forth. You'll understand as we, and the delivery time and lead time are held constant. Let's show you an example. So the optimum ordering quantity, the procedure for determining Q star has already been demonstrated. The number of orders will be D divided by Q star. How many times you're going to order? So total divided by showed you that, You'll make 5 orders, 6 orders, 7 orders, similar. And you can also get the cycle time between orders is Q star by D in years, okay, or demand per day. You will know how long the inventory works. So total annual cost is, we've shown it, half Q into H, this is the holding cost, plus D into S divided by Q star. Plus, this is when you're doing the annual cost, you should also get the cost of the inventory. So if your inventory is 38 into the cost of the inventory, the price at which you're going to buy. So these are the three components: the holding cost, the ordering cost, and you have to get the purchase cost also. So when you're working out price breaks, EOQ with price breaks, you must add this extra element. But just for calculating out EOQ, you just need holding and ordering. Okay, there's no need of purchase. So let us show you. I'll show you this with an example. You can just go through this. Determine the largest feasible EOQ. That is, calculate the EOQ as you normally did. Okay, as you normally did. 2ds by h under root. Do that. The most efficient way to do this is to compute the EOQ at the lowest price first and continue with the next higher price. Okay, stop when the first EOQ value is feasible, that is within the correct interval. Okay, so you'll understand this better. So you first calculate the EOQ in the normal way. Then you calculate the EOQ, you calculate the cost of inventory using that formula, calculate the inventory at the first price break. And you calculate the inventory at the second price break. Whichever is the lowest, you choose that. And you say, I will take this price break, or I will take that price break. So I'll show you that as an example. Compare the value of the average cost of the largest feasible EOQ at all the price breakpoints. At all the breakpoints you must calculate that are greater than the largest feasible EOQ. The optimal Q is that point at which the average cost is minimum. You'll see this with an example. Nick's camera shop carries, you can just see this. Nick's camera shop carries Zodiac instant print film. The film normally costs Nick $3.20 per roll, and he sells it for $5.25 per roll. Nick's average sales are 21 rolls per week. His annual inventory holding cost is 25%, in which case he has to take 25% of this thing, of 3.2, because to calculate the holding cost. His annual inventory holding cost is 25%, and it costs Nick $20 to place an order. So you know S is 20, and you know H is 25 into 25% of 3 rupees 20 paisa. Place an order. If Zodiac offers a 7% discount on orders of 400 rolls or more, and a 10% discount for 900 rolls or more, determine Nick's optimum order quantity. So how you will handle this? Okay, you'll take 25% of 3.2, that is 1/4, that is 80 cents. So the S will be 20, the H will be 25% of 3.2 is 80 cents, and the demand, the film normally costs, he sells, Nick's average sales is 21 rolls per week. So you calculate this, demand per week is 21 rolls. Okay, so it will be 2 into 21 into 20 divided by 0.8 under square root. So you'll get the EOQ. Then you calculate EOQ at this price. Now here what you're going to do is you're going to change. He says for 400. Okay, he's asking you for 400. So at 400, like just I did in the earlier case, instead of Q star, you use 400. Right? And calculate this, all the three. You must calculate the holding cost, ordering cost, and purchase cost for 400 and get the total cost. So one total cost based on EOQ, one total cost based on order of 400. Okay, because there the price is going to reduce by 10%. So, sorry, 7%. It offers a 7% discount on orders of this thing. So you're selling, now this $3.20 will become 7% less. So you must multiply 3.2 into 0.93 and then do the calculation, and do these three calculations. This will change. This will change. And then again do it with the 900. So it will be 900, sorry, ordering costs, all that with this thing. I'll show you an example with 900, right? 900, and this price 3 rupees 20 will be reduced by 10%. So it will become into 0.9. So it will be 30 cents. So it will be about 2 something. So what? And then see which is giving you the lowest cost, and then you can find out the economic order quantity. Now we'll work out, and that's the explanation. Now I'll give you with our own example so that there is no confusion. A firm is in the business of producing processed food products, has a requirement of 112 metric tons of wheat per annum. Should you maintain inventory if your lead time is ordering 15 and the price of wheat is 30,000 rupees per ton? Ordering cost is estimated at rupees 500 and the holding cost is rupees 75, just as we discussed earlier. What should be the economic order quantity? Like I told you, it's always the economic order quantity first, and we got a value like 38 tons per order. For orders in excess, now here he is giving you the discount. For orders in excess of for 40 tons, the company will give you a discount of 3%. And in excess of 50 tons, the discount will be 27%. I deliberately did this to show you how it works. Otherwise, you're not able to get the correct solution. So, if you buy more than 50 tons, he will give you 27% discount. He'll close down and go. It's like a clearance sale. If you take more than 50 tons, you can do it. Now, you want to know whether it should be you should order 38, or you should order 40, or you should order 50. What would be the most economical, the least cost inventory? So, say formula is the same, so you should not forget the formula. It's just an application of formula. Demand is 112, H is 75, and S is 500. 500. So, we get an economic quantity as 38.34 tons. Then we work out the cost. At 38.34 tons, holding cost will be, as we calculated earlier, half. Then half, instead of half, I put it as 0.5. Half into 38.34 into 75, because we've already decided this, plus 112 into 500 divided by 38.4. This is additional, plus 38.34 into 30,000 rupees a ton. This is the cost. Okay, so we get values like 1,437.5, 1,460.61, and this cost will amount to 11 lakhs 50,200. The value, total cost will be 11,53,098, which is the cost of holding an inventory of 38.34 metric tons, which is the EOQ. Now we have to evaluate the discount. At every discount, you must evaluate what is the cost. So once you decide EOQ, and you know it's 38, then you see at 48 tons, what will it be? So the same formula, instead of 38, you put 40, 75, so you get 5,500. Then 112 into 500 divided by 40 is 1,400. And 40, because now here you get a discount. Okay, here we got a discount. We'll just get it. You will get a 3% discount. So I multiply 30,000 by 0.97. I get 29,100. And then 29, so 40 is my order quantity into 29, because I'm getting a discount. It's not going to be as costly as before. I'm going to get this discount. So I calculated the discount. My cost becomes 11 lakh 64,000, and the total cost is actually higher. So if you go for just as the 3% discount is not enough, because it's still going to be costlier than the EOQ. It's rather you go for the EOQ. Now you come to the 50 tons. At 50 ton order, because he's giving you a 27% discount, I deliberately made it 27 to show you how it works. Again, this calculation. So 0.5 into 50 into 75 gives me 1,875. Then 112 into 500, which is the ordering cost, divided by 50 gives me 1,120. And the ordering cost, now this I've discussed, it is discounted by 27%. So it's 37 into 73 into 0.73 will give me 21,900, because 27% discount, no? 27% discount. So it's like multiplying it by 27 is 73. So 30,000 into 0.73 gives me 21,800. My cost, now my total cost becomes 10,97,995. So you go for the discount. You increase your, so your economic order quantity is not 38, but it will actually be 50, because you can reduce your cost of the inventory by availing the discount. So these figures may look a little unrealistic, but this is the principle. This is how it is done. First, evaluate the economic order quantity and the cost of it. Then you evaluate the first discounted value and get the purchase price and get the total cost. And if this is more than this, then you say, I will still go with the economic order quantity. But when you get this discount, it is much better to go for a inventory of 50 and avail the discount. Your cost of inventory will reduce from 11 lakhs 53,000 to 10 lakhs 97,000. So this is how price breaks are factored into the calculation of the economic order quantity. Okay. Now there is a concept known as reorder point. Like I told you, the reorder point is the point at which you will order the moment the stocks come to that level. So this way you can automate the process. So if there's somebody in your office, a clerk in your go down, he can just look at the order, and if the order comes to that level, immediately he can either inform the purchase department or he can place an order himself to replenish the stock once, because you know the economic order quantity. So this point is called the reorder point. So if the moment stocks come to that level, immediately you purchase, you place an order to buy. You know. So it's like this, when if you're running a big kitchen, and you're supplying food, and then the stocks come down to a particular level. You have only about 20 food packets left or 30 food packets left, and then it's going to take time for the food packets to come from some place. Then you'll know at that time I need to order, so that that will be in terms of hours. Then the order will come. By the time you're completely out of stock, then it gets replenished. So this can be applied in many cases. It simplifies the process of inventory. Okay, if there is a time delay from the time of placing the order for the stock and receiving it, it is called lead time. It's usually referred to as L. Lead time. It's called lead time L. Hence, orders have to be placed when you have enough stocks to last through the lead time. So this is called the reorder point. So the stock should last. So by the time the lead, because it's going to take time to reach you. So by the time it reaches you, your stocks may have come close to zero, and then you reorder. Then it gets replenished. So reorder point is a very simple calculation. It is just total demand divided by the total demand divided by the number of working days. Now the number of working days need not be always 365. If it's a 6-day week, it will be 6 2s are 12, 6 5s are 30. 30 is 312. If you're going to work 6 days in a week for 52 weeks, 6 2s are 12, 6 5s are 30, 31. So it becomes 312 working days. And if you're going to work 5 days in a week, it becomes 260. So it's 55 2s are 10, and 5 5s are 20, 26. So it's 260 working days. So depending on number of working days, you must divide the demand by number of working days and multiply it by the lead time. It will straight away give you the reorder point. So it's a very simple calculation. And I've shown you that, and what is the reorder point, we can see it a little later. Now, sometimes the reorder point may not be the right stock. Similarly, for instance, the lead time may vary. You cannot rely on it. Sometimes it'll take 3 days. Sometimes it'll take 2 days. 2 days, or 2 days, 3 days, 5 days, 6 days. So you just have a historical record of what is the lead time. So once I have a historical record of the lead time, I can convert that into a mean and a standard deviation. Okay, so assuming that lead time is fixed, the demand may not be a constant. So let's assume lead time is well within your control and it doesn't vary. But the demand can vary. And therefore you should have a safety stock. So the inventory should not be only exactly EOQ. In addition to EOQ, you should also keep a safety stock, and that's what's called a safety stock. So when your demand, so you'll have a historical record of demand, and you know that the monthly demand is not going to be constant, it's going to vary. So once it varies, then I don't have a one unit value of demand, a singular value of demand, but I'll have a demand and a standard deviation of demand. I'll have a mean demand and standard deviation of demand. Like for instance, assuming that the monthly demand is 50 tons and the standard deviation of monthly demand is 8.5 tons. Let's assume that that's a figure that you got. You calculated the standard deviation. Assume a normal distribution. Here, this is important. Assuming a normal distribution of monthly demand, then we calculate the 95% safety level, service safety level, service level safety stock. So that's called Q. Okay, so you should know the mean demand and you should know how much it varies. You calculating the standard deviation. I mean, these are simple formulas. You can do it in Excel, right? So you should get that safety stock. And once I know the mean and the standard deviation, I can calculate the service level safety stock, which is called K. Which is called K. This is what I need to estimate. So K is calculated using in Excel. You can say norm.s.inverse 0.05. Right? So please note of this. So once you know the mean and the standard deviation, you go to norms. Norm.s.inverse is in Excel. And you say for 5%. 95% confidence is 5% significant. So you'll get a value like 1.64. Right? 1.64. So now safety stock will become K into 1.64 into 8.5, which is a monthly demand. Let's assume that you've estimated this monthly demand based on 40 months. So here what I'm doing is I'm calculating the standard error. If this is a standard deviation, I'm going to collect the standard error. Now standard error is calculated as standard deviation divided by root of n. N being number of observations based on which you arrived at this mean and standard deviation. So I'm assuming that we have arrived at this standard deviation using 40 monthly observations, historical record of 40 monthly observations. So now I'm going to calculate the safety stock as K is what you get from here, into 8.5 divided by 40. You could have done it with 24 months, in which case this will be the root of 24. Okay, so that's what you do. So then that becomes 2.2 tons. So it says irrespective of your economic order quantity, add 2.2 tons to that, and that is called the safety stock. So very often inventory, companies do not want to get outstocked. They want to, even if they keep a little larger stock, they don't mind. But they should not reach a situation where they cannot produce the product and meet the demand. Because companies are very conscious of meeting demand. So that is why sometimes for an inventory, you need to keep a safety stock. And this is how that safety stock level is calculated. You need the service level of the safety stock, and the service level is calculated by just going to Excel and saying equal to norm.s inverse, open a bracket, and give your probability. If your probability is 90%, you give 0.1, and this will give you a different value. Right? And from that, you will get the safety stock. This is a rather simple calculation. There is no problem at all. Now, to show you the economic order quantity model once again, this is a repetition of what I did earlier. Just to show you the same thing, I'm just showing you what is the reorder point. I'm just showing you the reorder point. The reorder point that I showed you. We get the reorder point. Now, the safety stock is maintained mainly when the demand is not going to be a straight line. The demand will keep increasing, decreasing through the months, if this is 2-3 months. So we are assuming the demand curve is not a straight line, but it's going to vary. Here the demand is more, here the demand is less, here the demand is more. And then you will end up, if you order at the correct the reorder point, you'll end up that you will get exhausted from here. Okay, by the time you come here, you'll be negative. You won't have stock. Okay, you can see, instead of the inventory getting exhausted here, you'll get exhausted here. So that is why, when you do safety stock, you should know that this is, look, in the next year also it's like that. The next cycle also is like that. In such cases, we do what is called the reorder point. And the reorder point is S, which I just showed you the calculation. And we get the reorder point. And that, so your reorder point will not be at R, but it will be at S. Because it will be the reorder point plus the EOQ, reorder point, plus a little safety for any eventuality of it coming down. So you'll reorder not at R, but you'll order a little higher so that you don't run out of stocks. And that is called the safety stock. But the next and the final topic that we're going to discuss is called the single period inventory models. So single period inventory models are probabilistic models. So these are called probabilistic inventory models. Here you have a single and a multi-period model. A single period model with uniform distribution of demand. So that demand is uniform. In a single period model, the distribution of the demand is uniform. There is no pattern. Single model, you could have a single model with a normal distribution. Okay, it will be high in some periods, low in some periods. In a uniform distribution, you assume that irrespective of the time, the demand is the same. Okay, this is important. The probabilistic inventory model. The demand is known with certainty. Is not known with, sorry. The demand is not known with certainty. Demand characteristics such as mean, standard deviation, and distribution of the demand may be known. So you should know the mean, the standard deviation, and the distribution of the demand. Usually it's normal, but sometimes in an extreme case it may not be normal, and you should know what that distribution is. Now, when this happens, when the demand is not deterministic and is probabilistic, it's quite likely that you could get stocked out. Because the demand was too much, you ran out of inventory and you could not deliver. In the next month, your stocks were not, there were not enough stocks of your product. So that's called the stockouts. And stockouts come with a cost. Because when you get stocked out, then you're losing out a customer. No? So the costs associated with the loss of sales when demand cannot be met is called stockout. That could be over a long period of time, it can affect your sales. When your product is not available in the market all the time, customers have a tendency to shift, and then you will incur a loss, and that's called the stockout loss. For example, if an item purchased for 30,000, okay, this is what happens. Okay, for example, if an item is purchased for 30,000 and sold at 37,000, okay, then you have lost a profit of 7,000 rupees. If you don't have the stock, isn't it? So if you do not have, that is called the stockout cost. Now I ran out of inventory. I was not able to produce the product, and then I lost an opportunity of 7,000. This is called the stockout cost, and that's what you need to estimate. Now you have what is called a single period and a multi-period models. You have single period and multi-period models. This classification applies to probabilistic demand cases. A single period model, the item unsold at the end of the period is not carried over to the next period. Remember this. In a single period model, the item unsold at the end of the period is not carried over to the next period. Now think of a vendor in a market. She would have bought a whole lot of vegetables, fruits and vegetables. Let's assume that she's selling one item, and that is tomatoes. At the end of the day, whatever stock is unsold, she cannot take it to the next day because it will get spoiled. It will be of poor quality. The unsold items, however, may have some salvage value. If you go to the market at late in the evening, she will give it to you at a much discounted price. If she was selling it for 40 rupees a kilo, she'll probably give it to you for 15 rupees a kilo. Okay. Now, the good example of this is when you talk about calendars. Now, calendars are sold between September of this year till February of the next year. After that, after the year is over, or after that, there will be no demand. March, April, people don't buy calendars. So that calendar probably salvage value will be paper. So that is called a single period model. In a single period model, items sold at the end of the period cannot be carried over to the next period. Could be for vegetables, could be for calendars also. The unsold items however, have a salvage value. Right? You can sell it probably their vegetables to a hotel and they'll probably buy it at a cheap. In multi-period model, all the items unsold at the end of one period is available for the next period. So if it's rice or if it's wheat or if it's anything, if I don't sell it this period, I'll sell it for the next period. If nothing happens, it doesn't get spoiled. So please remember, this is the distinction between a single period inventory model and a multi-period inventory model. In a single period model and some of the multi-period models, there remains only one question to answer: how much to order? So the vegetable vendor who goes to the market, buys her stock of vegetables to sell in her push cart or in a wagon, will have to decide how much to buy. Because demand is not something that she has full control over. She has only a rough idea. She has only got an estimate that what should be the economic order quantity. The single period model is second only to the economic order quantity in its widespread use and influence. Okay, single period models are used, also referred to as a news vendor, or less politically, the newsboy model. It's like a newspaper vendor. Whatever stock he takes from the dealer, what he cannot sell, he cannot normally give it back. He has to keep it. He'll get paper value only. But the newspaper which he can sell for 5 rupees, he will probably sell the paper only for 20 paisa, 20 or 10 paisa or 20 paisa, because he has to aggregate it and sell it. So that's called that's called the single period model. The single period model differs from the EOQ in three main ways. First, while the EOQ assumes uniform and deterministic demand, it's a deterministic demand, it doesn't change. The single period model allows demand to vary, to be variable and stochastic. That's a reality. The demand is going to be variable. In such cases, single period models are more. Second is, so here the demand is in the EOQ, the demand is assumed to be constant. In the single period model, you assume that demand is not constant. It need not be constant. It could be stochastic. It could be variable and stochastic. Second, while the EOQ assumes a steady state condition, stable demand with essentially an infinite time horizon, the single period model assumes a single period at a time. So every year, whereas in the EOQ you're assuming the same pattern repeat year after year after year, go down, up, go down, up, go down. But here it assumes that it is only for a single period of time. Then the next difference, all inventories must be ordered prior to the start of the time period, and it cannot be replenished during the time period. Any inventory left over at the end of the time, single period, we're talking single period, left over at the end of the period is scrapped and cannot be used at a later date. If there is an extra demand that is not satisfied during the period, it is lost. Okay. If the vegetable vendor either has to destroy it, throw it in the garbage, or he has to sell it at a very, very discounted price. So whatever is left over is either scrapped, because you can't use it as that product. Thirdly, the EOQ, thirdly, for EOQ, we are minimizing the expected cost. You know that. While in the single period model, we are actually maximizing the expected profitability. So these are the three areas of difference between the EOQ and the single period model. We start the lesson, however, by extending the EOQ model by allowing planned back orders. Back orders means if I don't meet your demand, if I cannot meet your demand today, I will sell it to you. I will meet it tomorrow. Like you go to a shop and he says, no, I'm out, I don't have that particular product. Then the customer will ask you, when can I get it? He'll say, I'll give it to you in 2 days. That's called a back order. So what I supply over 2 years. So we start this lesson, however, by extending the EOQ model by allowing for planned back orders. So if your supply runs out and the demand is greater, it can be met at a later date. A planned back order is where we stock out on purpose, knowing that the customer will wait, but we do incur a penalty clause, which is called CS for stock out cost. So there is a cost. He may not pay you the same money. He may pay you a little less. So that's called the CS. So you should pay careful attention to these terminologies. So the penalty cost is called CS, or the stocking out cost. C subscript S. From this, we develop the idea of a critical ratio. Now, this you must pay very attention. In single period models, critical ratio is very important. So, from this, we develop the idea of critical ratio, CR, which is the ratio of the shortage cost, CS. Nobody says it's called shortage cost. The cost of shortage or having too little product to the ratio of the sum of the shortage cost plus the excess cost. That's something, etc. So sum of the shortage cost is CS, and CE is called the cost of having too much of excess product. So the critical ratio is CS divided by CS plus CE is the excess cost, and that gives us a critical ratio. So this is a ratio. The critical ratio is, by definition, ranges between 0 and 1 and is a good metric of the level of service. A high critical ratio indicates a desire to stock out less frequently. So this you need to calculate. Okay? A high critical ratio indicates a desire to stock out less frequently. That means stock out is not desirable. We are going to lose heavily. The EOQ with planned back orders is essentially the generalized form where CS is essentially infinity, meaning that you will never ever stock out. Okay, so you can just say that is essentially infinity, meaning that you will never stock out. So it is critical ratio, where C is essentially infinite. No, critical ratio, not C. The critical ratio is essentially infinity. That is 0 divided by 1 is infinity. 0, sorry, 0. Okay. So the CS gets smaller. So as the CS gets smaller, the Q star PBO, probability of outstocking, gets larger. And a large percentage is allowed to be back ordered since the penalty for stocking out gets reduced. So remember that. Huh? So as the CS gets less, then the economic order quantity gets larger as a larger percentage is allowed for back ordering. So because you can back order, it's called PB is back order. Okay, it is inventory based on back orders. So when the CS, that is a cost of penalty of back order, of stock out is less, then the back order becomes very, very large. The critical ratio applied directly to the single period model as well. The critical ratio applies directly to the single period model as well. We show that the optimum quantity Q star occurs when the probability that the demand is less than Q star is equal to the critical ratio. The critical ratio applies directly to the single period model as well. We show that the optimal order quantity Q star occurs when the probability of demand is less than the Q star. So when demand is lower than your inventory, okay, then Q star, which is that is equal to the critical, you'll get the critical ratio. In other words, the critical ratio tells me how much of the demand probability that should be covered in order to maximize expected profits. The critical ratio tells me how much of the demand probability that should be covered in order to maximize my profit. So that's why the critical ratio is very, very important. So please see this. This is a critical ratio. C divided by CS plus C, cost of excess. So there's something called the marginal analysis of the single period model. So the two costs associated with the single period model are the excess cost, CE, where demand is less than the supply because you got excess. Okay, when demand is greater than supply, there's too much of product. Sorry, when demand is greater than when demand is greater than the quantity supplied, there is too much of demand. There is too much product. There is too much product because of excess demand. So this is the cost of excess demand. And shortage cost is CS, where demand is less than the supply. You take Q as supply. When demand is less than the supply, you get the excess cost. And when demand is greater than the supply, you get the shortage cost, which is also called the too little cost because it's your shortage. No? Demand is more. So you get this is a penalty. We said there is a penalty of stock out. So you'll have a stock out here, but you'll not have a stock out here because the amount of supply that you have is greater. So here you're in excess. So this is called cost of excess. Okay. If we assume a continuous distribution of demand, then CE, that is cost of excess, is equal to the expected excess cost of Qth unit ordered. So it tells you, it gives you the expected cost of the Qth unit ordered because there is a cost, there's a cost of excess, and the cost of shortage is the expected shortage cost for the unit ordered. Okay, we'll examine it later. This implies that if the excess cost is less than the shortage cost, excess cost is less than the shortage cost, then increase Q, and that we have Q star, increase Q and you get 2 star when E shortage cost is exactly equal to the E excess cost. So they should become equal. So you go on varying the Q till you get Q star, and Q star is that point where shortage cost is equal to the excess cost. Little imagination. You have to use your imagination. So it is Q when excess cost is less than the shortage cost. So as we increase the Q, they'll become the same. Okay? They'll become the same. So we are essentially trying to find out this Q star. Solving this gives us the probability that X is less than Q, and that is calculated using the. So the probability that X is less than Q, that is the quantity demanded is less than the quantity supplied, is given by, so that gives us the probability. You can see that it can be used as a probability. So Q as shortage cost divided by shortage cost plus excess cost. In other words, it means that the percentage of the demand distribution covered by Q should be equal to the critical ratio in order to maximize expected profits. And this is very important. In other words, this means that the percentage of demand distribution covered by Q should be equal to the critical ratio in order to maximize profit. So your demand, okay, to be covered by the Q should be equal to the critical ratio, which is nothing but your CS divided by CS plus C. Now you can see this. Now B is the penalty for not satisfying demand beyond lost profit backorder demands. So penalty for not satisfying demand beyond the lost profit and backorder demands. Okay, so you have backorder, you can meet it. Okay, so that is B. It's a penalty for not satisfying the demand. Right. B star is the optimum units of back orders when placing an order. Now, all your demand is not going to be absorbed by back order, only a certain amount. And that certain amount that is going to be absorbed is called B star. C is the purchase cost of the item. How much does it cost to buy the item? CT is the ordering cost, just like EOQ. And CE is the excess holding cost. So these terminologies you must just get to understand. So B is the penalty for not satisfying demand beyond a particular level. B star is the optimum units of back orders when placing an order. So you get the optimum. C is the purchase cost. CT is the ordering cost. CE is the excess holding cost, which we just discussed a little while ago. CS is a shortage cost. You're familiar with it. D is the average demand. G is the salvage value. Now we have introduced a new term, salvage value. So sometimes when your product is not sold, you cannot sell it at the market price. You have to sell it at a discounted price, and that price is called the salvage price for excess inventory. H is the holding cost, just like in a EOQ. L is the lead time, replenishment time, or it's called the lead time. Q is the replenished quantity. So that is what we are really trying to drive at. This is important. Q PBO, optimum order quantity with planned back orders. So if you have the facilities for satisfying back orders, that is that demand that is not met today can be satisfied at a future date, then your Q, which is a replenished quantity, gets changed to Q PBO, which we shall discuss as we go along. T is order cycle time, that is nothing but economic order quantity or the inventory divided by the demand per day. Total relevant cost, just like total cost, it's called total relevant cost and total cost. So these are the terminologies that you should, these are the terms that you should get familiar with. B, B star, C, CT, CE, CS, D, salvage value, holding cost, replenish cost. QPB, optimum order quantity with planned back orders. Planned back orders. Cycle time, total cost. Okay. Now here also you will have formulas. Now we're going to be getting into the single period models for economic order quantity with planned back orders. So this is an extension of the EOQ with the ability to allow for back orders as a penalty of CS. So there is possibility that if you don't sell it today, the same demand, they will come tomorrow and they'll buy it from you. So you can see the total TRC, QB. You can see what is that. TRC, total relevant cost. So TRC for Q and B is equal to C into D by Q. plus C into C is ordering cost. C purchase cost, right? So you can just have a look at C into D divided by Q plus C into Q minus B, which is that economic order quantity, raised to the power of 2 divided by 2 into Q divided by 2Q. CS is equal to B squared divided by Q. So you are getting the two. You can see it's a quadratic. So you'll get. So here we get Q star optimum with probability for back order. With the probability for back order is calculated very simply as Q star into 1 by CR. Very, very simple. You know what CR is. CS by CS plus C. So it's very simple. You get the Q, and then you provision back orders, and then you calculate it by calculating Q into 1 by CR. So very, very simple, straightforward calculation. Now you can calculate B star. Now B star is equal to 1 minus critical ratio into Q PBO. Right? And T is equal to D, that is a cycle time. Then after all the order becomes the same. So order Q PBO when IOH is equal to minus B. Order Q for every time period. That of course that's understood for every. So this is the principle. Right? This is the principle. So we'll just see this with a numerical. I mean, we can, it's very simple. You calculate EOQ, you calculate the EOQ, Q star, and multiply it by 1 minus CR. So now you need the information on that. I will just show you with an example. The single period model, computers that will be obsolete. The example of single period model, when computers will become obsolete before the next order. So that is usually done in single period. So the computer has to be junked. So whatever you don't sell, you have to sell it at a highly, as what you call you must sell it as a sale, and therefore you lose a substantial amount of money. And that is called the CS. Okay, that is called the CS over here. That's the CS. Stock out, cost of stock out. Perishable products, yes, simple period model is very relevant. Seasonal products such as bathing suits, blankets, soft drinks, winter wear, newspapers, magazines are all examples. So this is what we basically boil down to. Loss resulting from the items unsold. So what you happen when you have items unsold, the purchase price is the same, but you'll sell it at what is called as a salvage price, so that is called the loss. Okay, it's called ML for loss. It's nothing but C. Profits resulting from the items sold, that is MP. This is CE. Okay, this is selling price minus purchase price. Given cost of overestimating, underestimating demand, and the probabilities of various demand sizes, how many units will you order? But this happens because you're not estimating the demand and the supply properly, and that is why you should take that into consideration in the single period models. So you please see ML, purchase price minus salvage value, MP, selling price minus purchase price. So you can notice that both are positive. Purchase price will always be higher than salvage value. Selling price will always be higher than purchase price. Consider an order quantity Q. Let P be the probability of selling all of Q units, probability that demand is greater than or equal to supply. Okay, that is the probability. That is Q. Then 1 minus P is the probability that you won't be able to sell. So if this probability is 0.8, then the probability that you won't sell is 0.2. 1 minus 0.8, which is 0.2. We continue to increase the order size so long. Now we'll go on increasing the order size. Okay, we'll go on increasing the order size till the probability of MP is nothing but this. Probability of MP here, this one. Probability of MP is equal to or greater than or equal to 1 minus probability of ML. Right? And where do you get that probability? This. There's something like, see, this is something like a critical ratio. There's something like a critical ratio. Okay. So this gives you the probability. So this is the probability which you should keep in mind. So just to recollect, this is the formula. So from the Q star into 1 minus critical ratio, 1 divided by critical ratio. Okay. So it should be 1 reciprocal. So it should be C plus S divided by S. Okay. So that's what you should remember. So we continue to increase the order size till this. So the order maximum quantity Q such that P is greater than ML divided by MP plus U, where P is the probability that demand will be greater than the supply. So here is an example, more or less related to the example that we did in our case, where we are studying the demand for wheat, and we notice that in 5% of the cases, the demand for wheat was 80 tons. In 10% of the cases, demand was 90. In 20% of the cases, demand was 100. 30%, the demand was 110. The 20% of the cases is normal distribution. Now here we get. Now we're going to the selling price of the product is 37,000. This is the same wheat example. The cost is 30,000. The salvage value, if I can't sell it now, I'll have to sell it for 20,000. This is called the salvage value. Right? So we have got this. We got that. Now we can calculate ML, MP. Okay. Yeah. Construct a table showing the profits or losses for each of these quantities. What is the optimum number of wheat products to make? Solve the problem by marginal analysis. So this is basically how the data will look like. Okay. So when we do the marginal analysis, so first we calculate what is called as the marginal loss. Now, for instance, if a seller of fruits has gone to the market and bought a fixed quantity of fruit, at the end of the day, what is not sold, either he'll have to sell it at a very discounted price to somebody, or it has to be discarded. So there is a purchase price. When you calculate the marginal loss, here the purchase price is assumed to be 30,000 rupees a ton for wheat. And if it is not sold on that day, it has to be sold for 15,000. So the salvage value is 15,000. So the marginal loss, so all marginal analysis is done on a per unit basis. So 30,000 minus 15,000 is the marginal loss if a particular item kept in inventory is not sold and it cannot be carried over to the next year. Alternatively, you have what is called as a marginal profit, abbreviated as MP, is the selling price minus the purchase price. Now we know that the selling price is 37,000, the purchase price is 30, so the marginal profit is 7,000 rupees. So if the seller is able to sell the product, if there is demand for his product, then he will get 7,000 rupees for every quintal of wheat that he sells. But if he is not able to sell it on that particular date, he will have to sell it for 15,000, as a result of which he'll incur a loss of 15,000. So now from this we calculate the critical ratio. The critical ratio is cost of shortage divided by cost of shortage plus cost of excess. So now we know that the cost of shortage is 15,000, marginal loss due to shortage is 15,000, and the marginal profit due to marginal profit is 7,000. So now we calculate the critical ratio as 15,000 divided by 15,000 plus 7,000, which is equal to 0.68. Now this is called the critical ratio, which is very useful and very important when we take decisions when it comes to single period models. Now we will see how it is employed. So first what we do is we prepare what is called the trade-off matrix. So given the cost of overestimating or underestimating demand and the probabilities of various demand sizes, how many units should we order? So any trader would have roughly, based on historical data, he would have been able to estimate that he was able to sell, the demand was 80 tons per annum, and that happened in 5% of the cases. 90 tons per annum, it happened in 10% of the cases. 100 tons per annum, it happened in 20% of the cases. 110 tons per annum, it happened in 30% of the cases. 120 happened only in 20% of the cases. 130 happened only in 10, and 140 only in 5. So he has this information. So this is the empirical data that he has. So based on this empirical data, the single period model can be analyzed in this fashion. So what we do is we arrange this. We arrange it like this. Okay, we have the demands, then we have the probabilities of those demands, and here I've just kept the marginal profit and the marginal loss and the critical ratio. We'll use it later. Now this is the inventory that he has. Now supposing he has an inventory of 100 and the demand is 100, he'll sell the entire quantity. So he'll sell 80 tons and he'll make a profit of 7,000 rupees a ton. So the value that he enters here over here will be 80 into 7,000. But if he has 90 units of stock and the demand is 100, so he'll be able to sell 80 for 7,000, and he will lose on 10 units, he will lose 15,000. So it will be 80 into 7,000 minus the difference, which is 10 into 15,000. That value will enter over here. And similarly for the others. I'll just show you in an Excel sheet how this is done in an Excel sheet. Okay, the same data I've got over here. So what I'll do is, I'll say equal to 80 multiplied by 7,000, because able to sell the entire quantity. There is no loss. Okay, so I will fix this. I'll fix this with F4 and I can drag it. Because if he has 80 quantity of stock, he can sell only 80. He can sell only 80. So, mistake. I fixed the wrong one. But that doesn't change, and just fix it with F4. And the price also doesn't change. I'll fix it with F4. Okay, so you'll notice that since he has only 80 inventory items in stock, 80 tons, when its demand is 80, he can sell only 80. When demand is 90 also, he can sell only 80. When demand is 100 also, he can sell only 80. So he keeps getting this 5,60,000 rupees. Now, if his supply is, we'll go by the diagonal. Now let us assume that his inventory is 90 and the sale is 90. So he can realize 63,000. We'll go here. Let us assume that his inventory is 100, demand is 100. He will get 7 lakhs. So here his demand, his inventory is 100, demand is also 100. Inventory is 110, demand is also 110. He will realize this profit. So when his inventory is 120, demand is 120, he can sell the entire quantity and he will make a profit of 8,40,000. When his inventory is 130, demand is 130, he will make 9.1 lakhs. And when the demand is, when his inventory is 140, and he also has a demand of 140, then all of the inventory will be sold and he'll make 9.8 lakhs. But supposing he has an inventory of 90 and the demand is only 80, that means he will sell all the 80. So that will be 80 into 7, this one. And on the remaining, the difference between 90 and 80, the difference between 90 and 80, he will lose 15,000. So his total revenue is not 5,60,000 because he has a certain amount of excess inventory on which he will have to sell at a salvage value, and it will become 4,01,000. I'll just take a value here, somewhere here. Now here what happens? So he will sell 90 units because the demand is 90 units. Okay, and on the difference between, that is about 50 units, and he has 130. So his demand is 110 and he's got 130, he can sell all the 110 and make a revenue of, make a profit of 7,000. But he will lose, he will lose on 30 minus 110, which is about 30 minus 110. He will lose about 15,000 rupees, and his net revenue will be only 40,000. 4,70,000. So this matrix gets populated in this fashion, and I will demonstrate it over here. So fill it up. Now, obviously the diagonal elements will be progressively increasing. Now deciding what is the optimum quantity that he should trade. Okay, we have to decide a set of rules. Now, how do we do that set of rules? Okay, what we do is, okay. So what we do here, now this is a very simple rule. It's the same data, 85% with the probabilities, right? So 5%, 10%, 5%. Now, how do we calculate this 0.68? It is marginal loss divided by marginal loss plus marginal profit. You get 0.68. Alternatively, you can do as marginal profit, 7,000 divided by 7,000 plus 15. You can also calculate critical ratio like that. So the value will be different. Let me just show you. Now, supposing you divide 7,000, supposing you divide 7,000 by 22,000. So it's 7,000 in the numerator, because that is a marginal profit, divided by its total, which is 22,000. You'll get a value of 0.31. 0.31. Roughly, it's not exactly the reciprocal. You'll get 0.32. You're exactly getting the reciprocal of that. Yeah. Okay. So there is significance. Now, supposing you calculate critical ratio as marginal loss divided by sum of marginal loss and profit, then you must start from the bottom. You may see I'm accumulating from the bottom. I don't accumulate from the top. You will see that I don't accumulate from the top. I will accumulate from the bottom. That's very important. It's very important. So what I'll do is I will take 0.5, put it here, and then I will accumulate. I'll say this plus this. So it becomes 0.15. Then I copy this up and I get accumulated from the bottom. Okay, that's important. When I am using critical ratio as marginal loss divided by marginal loss plus marginal profit, 0.68. And then it becomes very simple. Now move upwards till you get this critical ratio 0.68. Now 0.68 will lie between these two. 0.65, and then it will go to 0.68 and then go to 0.85. Then you know that economic order quantity, so your order quantity, Q star, that is with back orders, with probability of back orders, will be 110. So please remember, you get this. Supposing you take 0.31, then I must aggregate it like this. If I'm going to do it with the other one, then it will be like this. I'll accumulate from the top. It's not going to be the same. You'll get 1. Right? They'll accumulate from the top. And then wait for 0.31. I'll get 0.31 somewhere here. 0.32. 0.32 will be somewhere in between. 0.32, yeah, around here. So it'll be around 100. So that's a little thing over there. So that is how I decided. So you don't worry about that. You take this 0.68, move from the bottom, see where you get. Oh, so good. Sorry, you get 0.68. You'll get 0.68. Oh, sorry, here. You have to look up this. Okay. So move up. You keep going. Then 0.68 will come here. So it is anything between. This thing. It'll be it'll be usually 110 will be your Q star. So this is how you decide it based on empirical data. Now supposing you had empirical data, this is how you calculate. Now alternatively, you may have a distribution. It may not be such as simple as this. So this is how you calculate it. ML divided by MP by ML, which is called decision rule, order minimum quantity, such that the probability should be greater than this. So when the probability of demand is greater than equal. Okay. Now just assume that you have a distribution. The mean demand has been estimated. The mean demand has been estimated by you as 110. Okay. So let's say this mean has been estimated as 110. You've estimated this mean. The mean, yeah, I'll show you how that mean is estimated. Let's go there and get an estimate of the mean. Okay. Now I'm going to calculate the mean. Now, how do I calculate the mean? The mean is nothing but demand into probability of demand. Okay. They call it expected value. So expected value is x into p of x. So I can do it easily. I can do it quite easily here by, let's make it a little big, by a sum product. So I'm going to calculate mean, okay, which is equal to sum product of this with this. So that you don't have to divide, right, comma, with the probabilities. Close the bracket and enter. So the mean is 110. Now I'll calculate standard deviation. Okay, so standard deviation will be, I'll create a new variable which will give you the difference. It'll give me the difference now. It'll give me the difference of 80, I'll use a bracket. So equal to 80 minus the mean, which I have to fix with F4, function F4. It's fixed. Close the bracket, raise it to the power of 2. Okay, so I get the square x minus x bar. Okay, yeah, whole square. And then I will take a sum of that. I'll take a sum of that. Oh, you can do here also I can do a sum product, equal to sum product. Sum product of these deviations by their probabilities, multiplied by the probabilities. Close the bracket, I get 210. Sorry, this is a variance. And from the variance, I'll calculate the standard deviation. Standard deviation as the square root of this. So I get a standard deviation of 14.9. Now I want to know, with this mean, with this standard deviation, and with these probabilities, what is the economic order quantity? Now I'm assuming a distribution. I'm assuming a distribution and a normal distribution, and trying to estimate what is the optimum quantity in a single period model, which we've discussed in great detail. So here what I do is I take recourse to this normal distribution. So this is 110. I want to know what is the value that corresponds to what the probability. Now I have to go back to this probability. That's where it's important. I have to go to get this critical ratio. Now this critical ratio is 0.68. Now I want to find out in this distribution, okay, this is 110. So the probability of this 110 is 0.5. I want to find out the value corresponding to 0.68. So this up to here is 0.5. This whole area is 0.5. So obviously 0.68 will come over here. And I want to know what is the x corresponding to that. And that is the Q star. That is a Q star. This is mean quantity. And I'm going to calculate what is the optimum inventory when the demand is going to change and I have to dispose of the product in the evening. There is back orders. All these assumptions are there. So this is what I'm going to now show to you, which is now I'm going to show it to you. So now I've got the mean and the standard deviation. I'm now going to find out the value corresponding to 0.68. Okay. So here what I do. So here I'll take norm inverse. So here I will take what is called as norm inverse, equal to NORM, norm inverse. So it's asking me what is the probability. The probability is 0.68. It's asking me what is the mean. I say the mean is 110. And then it's also asking me what is the standard deviation, which is the square root of the variance, and I get this will give me the Q star, which is 116.77. It becomes 116.77 or 117. 117 becomes the economic order quantity. There's a quantity, maybe somewhere here. It's here. And this line and this line from here to here, this area is the critical ratio, CR. So it's very easily, once you understand the concept, you from the critical ratio straight away you can get the economic order quantity, calculations notwithstanding. Now the calculations are done only to make you understand how it works. Now let me go back to this example, where where we've got the cumulatives. Okay, let's work it out. So we'll go same way. We'll go same reverse way. We decided that 0.68 is somewhere over here. Yeah, this 0.68 is somewhere between this and this. Okay, so now let us try to calculate. We'll calculate the values that we want to work out. Okay, now 0.68. Now I'll call this as profit, marginal profit, and I'll call this marginal loss. Right. Now we come here. I will take it over here. So the marginal profit is the quantity demanded into the critical ratio. Critical ratio. Right. And the marginal loss. Okay, sorry. Okay, this will be marginal profit. It will be marginal profit. That is 7,000. We calculated that earlier. We had that marginal profit. Yeah, just marginal profit into critical ratio, and this will be marginal profit, marginal loss into 1 minus critical ratio, 4,800. Right? Then I will take it here also. So very clear. Marginal profit into critical ratio will give me the gain. Oh, no, sorry, I made a mistake. Marginal profit into this probability, cumulative probability, gives me the marginal profit, and the marginal loss will be marginal loss into 1 minus this probability. This is a probability that it will happen, that you will make profit. Okay. Sorry. Into 1 minus, must pay careful attention, 1 minus this. This is the probability that you will make profit. This is a probability that you won't make profit, will be 1 minus that. Similarly, we do this. Please be clear. So, marginal profit into the probability of making profit. Marginal loss into the probability of not making profit is 1 minus that. And the third one will be equal to marginal profit into the probability of making profit and the marginal loss into the probability of not making profit makes it 1 minus 0.35, right? Closing. So if you work out, you will notice here marginal profit is greater than marginal loss. Here marginal profit is equal to marginal loss, and that's why I got the optimum at 110. And here marginal loss is less than. So I won't go here because my loss is greater than my profit. Here my profit and loss are more or less equal. It's not exact, it's more or less equal. That's how I got this point. Actually, it should be a little more where it will come exactly equal. This will become 4.6, that will also become 4.6, they'll become the same. And this is how they decide. So I take it that my economic order quantity with back orders is 110 tons. So here it is very profitable. Here you should get 0 because I've explained it earlier. This the marginal loss should be equal to the marginal profit, and that is what gives you the economic order quantity. So you should understand how it is done. Okay, so this is how single period models are solved using when you have a distribution of yields, and when you think that the yield when you have historical data. When you have historical data, then you use your own data. You'd use your own data, and you cumulate it, and please remember, cumulate it from the bottom if your critical ratio is loss divided by profit. If your critical ratio is profit divided by loss, then you move from the top downwards. Okay, so that's what you should remember. So, and another thing that you should remember. Now, if the critical ratio or this probability is equal to 0.5, then you can take the median of the demands, median of the demands, and that can be used as a basis for deciding Q star. Now, as the loss becomes more, as the loss becomes more, that is ML is a big number, MP is a small number, then your economic order quantity will go down very, very less, right? It will become very less. Similarly, if the loss becomes more, if the ML is a very small fraction, if the ML is a very small fraction of the total, or the critical ratio is a very small value, then it's an indication that you can have large inventories and you can afford to backorder. Okay, so this is another data which you can just have a look at, take it down, and try to solve using these methods that we have explained so far, where the demand is going on changing. Now from this I should be able to find out what is the probability. I'm giving you the number. This is data that on one day 14 quintals were sold. On 2 days 15 quintals were sold. On 11 days 21 quintals were sold. Now it follows a distribution. So you have to calculate the mean and standard deviation. It follows a distribution. Mean is 20, standard deviation is 2.49, right? And you have to calculate this distribution, calculate that value, ml by mp. ml is 2 and mp is 1.5. So it will become 0.5 divided by 2. So 0.5 divided by 2 becomes 0.25. So your value is look, this is how you get that value. You get an area of 0.25. Go to the norms dist, find out the value corresponding to this, and that will be your demand that you should be estimating. Okay, so there's another problem which you can think of. A retail outlet sells seasonal products at $10 per unit. The cost of product is 8 per unit. All units are not sold during a regular season and are sold for the half the retail price at the end of the season, clearance sale. Assuming that the demand for the product is normally distributed with mean mu, with mu 500, standard deviation sigma, what is the recommended order quantity? So please work it out, and unless you work, you will not be able to. What is the probability of stock out? That is very important. To keep customers happy and return to the store later, the owner feels that the stock out should be avoided, if at all possible. What is your recommended quantity if the owner is willing to tolerate a 15% probability of stock out? So that's important for you. So using your answer on part C, what is the goodwill cost you have assigned to a stock out? So here it is. So selling price, mean and standard deviation, is calculated as Z at 25. Purchase price is 8. Salvage value is half the price, he said. So 10 divided by 2 is 5. So marginal profit is 10 minus 8, that is 2. Marginal loss is 8 minus 5, which is 3. Order the maximum quantity Q such that ml by ml plus mp is 0.6. So now you have to look at that 0.6 value here. If you look at the 0.6 value and then 0.6, you look at 0.6 because it's up to 0.5, get the 0.6 value. That is 0.1 on this side, so this is because of table. But if you have Excel, you just say norms this, in norms inverse, in bracket you say 0.6, mean 500, standard deviation, whatever the standard deviation is given you. So you put standard deviation is standard is 100, and you'll get the value directly, and that is your order quantity. Okay, so that becomes your order quantity. So that is it. I hope you've understood. Thank you very much.